In this lesson, we're going to talk about special refrigeration system and the applications. This is a two-part lesson, so when you're done with this one, we need you to listen to the version B that's also there. We're going to start off with transportation refrigeration. It's in four categories: conventional, expendable, ice, and dry ice. These are truck systems designed for various ambient temperatures and operating temperatures. The truck must be able to withstand stress, vibrations, and it may utilize backup units. Truck refrigeration requires special trailer bodies and refrigeration units. Bodies are light, well insulated with foamed in-place insulation. This is an example of a trailer body. You'll notice the foam and the cabling and everything. Main components of the refrigeration system on a trailer are the compressor, an air-cooled condenser, expansion valve, and a direct expansion evaporator. Not too much different from a standard refrigeration system. R134A is commonly used as the refrigerant. It has replaced R12 in most applications. The application determines the temperature. Fresh food requires insulation for 32 to 35 degrees. Fresh food includes flowers, produce, and they require accurate control of temperature, humidity, and ventilation. The four main components of the truck refrigeration systems are the mechanical. It has a blower system. It might have a holdover eutectic plate. Could be expandable refrigerant, such as liquid nitrogen or liquid carbon dioxide. Could be ice or dry ice. The mechanical refrigeration is similar to typical refrigeration units. Difference is in the compressor drive. There's two common drives. First, you have an engine-driven electric generator or motor. You could also have a separate gasoline or diesel engines. Electric generators and motors use standard voltages, cycles, and phases. The unit may be kept plugged into a wall outlet so the trailer is kept cold while off the road. Units driven by gasoline engine are automatically controlled to stop and start as the system requires. Some vans or short truck use a cube-style or thin-line wall-mounted evaporator. A roof or body-mounted condenser and an engine-driven compressor are used. A remote cab command control is used and includes a solid-state temperature controller, temperature selector, and manual defrost operations. You'll notice the condensers on the front, the evaporators inside, and there's a road compressor. Refrigerant lines run from the engine to the back. Sometimes this is a standby motor-driven compressor. Okay, you'll see the electric standby motor. Might have a muffler and an engine inside of it. A compressor mounted above and driven by the engine may be also used. Most use hot gas defrost. Larger commercial units may use diesel fuel. A generator may provide power for the evaporator fans. The Eutectic plates normally operate without mechanical assistance. A small electric condensing unit is connected at night. It freezes the eutectic solution, storing enough energy for cooling throughout the day. The plates act like a battery by storing energy. It's constructed of small diameter tubing for circulating refrigerant. Fins attached to the tubing conduct heat from the refrigerant into the eutectic solution. Assembly is inserted between the two steel pans. The condenser is vacuum filled with eutectic solution that freezes at specific temperatures. Ice and dry ice are seldom used today because of weight and load requirements. Dry ice is also difficult to control and maintain at specific temperatures. Railcar refrigeration is a little bit different. Most often they use mechanical refrigeration. The car's construction and installation are similar to the truck trailer, and there are two types of cooling requirements. First, you have freight refrigeration, and second, we have passenger car air conditioning. There's four methods of freight refrigeration: mechanical, chemical, ice, and dry ice. The compressors in the mechanical installation are driven by the car axle while rail cars are in motion, and electric motors used while the cars are stopped. Some train refrigeration systems use an absorption system, others use a steam jet system. The marine refrigeration on boats is similar to land-based refrigeration. Refrigerants are restricted to those that are non-toxic and non-flammables. Cabinets are carefully sealed to avoid moisture entering. Lines must allow for some vibration or movement, and saltwater-cooled units must use materials that minimize the corrosive effect of salt water. Some equipment is automatic, some equipment is semi-hermetic and interconnected. The capacity can be adjusted to varying loads. Most often R124 is used as a refrigerant. Expendable refrigeration systems use liquid, non-toxic, low-temperature refrigerant. Uses liquid nitrogen or liquid carbon dioxide. It's used in the cooling of rail cars and shipping containers for perishables. It's similar to a vapor system, but it has no condensing unit. Expendable refrigeration can also be used as referred to as chemical or open cycle refrigerant. A refrigerant's latent heat of vaporization is a measure of its heat absorbing ability. Both liquid nitrogen and liquid carbon dioxide are fairly high in latent heat of vaporization. The carbon dioxide boiling temperature is at negative 109.3 degrees Fahrenheit and nitrogen is at negative 320.5. The latent heat of vaporization for carbon dioxide is 275 BTUs per pound and nitrogen is 173 BTUs per pound. A cold plate cooling system consists of liquid refrigerant stored in large metal insulated cylinders located in the front of a cargo vehicle. Each unit has a temperature controlling, providing a temperature range of negative 20 to 60 degrees. This is an example of the cold plate cooling. Notice the manifold and valves, the liquid nitrogen cylinders. The temperature control is connected to a temperature sensor. As the temperature rises, the operating control valve is open and liquid refrigerant flows into the evaporators. The evaporator may be blower coils, plates, or Eutectic plates. Liquid refrigerant passes through the plates and vaporizes. Vapor is forced through the plates by a pressure difference. When the desired temperature is reached, the refrigerant valve closes. Used vapor leaves the evaporator at about the same temperature as the cargo airspace. No refrigerant mixes with the air in the interior of the vehicle. Spray system cooling is also used by transport vehicles. Liquid nitrogen or carbon dioxide is sprayed directly into the refrigerated space. Nitrogen turns to vapor inside the cargo area. The vaporized refrigerant replaces the oxygen in the storage space, better preserving perishables. Systems contain similar parts as the cold plate method with the addition of spray headers, emergency switches, and safety vents. This is an example of a spray system cooling. Notice the spray header down. You have a sensing bulb, you have piping guards and containers. There's a safety vent door at the back of the truck, and there's an emergency shutoff valve directly inside the trailer. The spray system works in the following sequence. Liquid nitrogen is pumped into the storage cylinder by a fill box. When the containers are filled, the cargo space is loaded. Temperature selected on the main control. A temperature sensing device anticipates temperature changes in the cargo space. When the cargo temperature rises above the set temperature, the controller opens the liquid line solenoid valve, allowing liquid refrigerant to enter the spray header. It becomes a vapor and maintains the desired temperature. The units may have a primary and secondary container filled in series. As the primary container is filled, the liquid refrigerant flows into the secondary container. The spray header system is usually a perforated pipe, usually mounted along the roof at the center of the cargo compartments. Nitrogen tanks have safety valves that open if the container rises above 22 psi. Nitrogen would be then released to the outside of the vehicle. The truck body may have electric heaters for times when the truck is exposed to temperatures below the required cargo space temperature. You need to always read warning labels on refrigerated vehicles prior to entering them. Liquid nitrogen released from the spray is at sub-zero temperatures. It will freeze flesh instantly. Be certain no living animal or human is in the refrigerated space when the doors are closed. The interior of the expendable refrigerant system must be free of dirt and moisture. Pressure test piping using nitrogen or helium. Refrigerated containers are used on ships, trucks, railroad cars, and planes to store perishables. They may be up to 8 by 8 by 20 feet. For long distances, containers may have an evaporator and a condensing unit. The condensing unit may be driven with an electric motor or internal combustion engine. For a short distance, you can use the Eutectic solution. That's the one that stores the energy. The evaporator freezes the solution that is part of a cold plate, providing cooling for a short time. Containers on ships may be connected to the ship's central refrigerating system. A refrigerating mechanism is using an electric motor, and condensing unit could also be plugged into an outlet and powered by the ship. The condensing unit is usually water-cooled. Portable air conditioning and spot cooling is usually used to spot cool specific areas. They're mounted on casters. The evaporator and condenser are packaged together as a single unit. This is used very often in construction situations. Condensate is collected in a drain tank and may be manually drained or may use a pump. Warm air flange and duct are attached to the top of the unit to remove the warm condenser air. When used in an office, the warm air may be placed into a drop ceiling, or the cold air may be ducted into the room in need of cooling. We use portable air conditioning and spot coolings in situations where primary cooling for people exposed to hot operations such as welding, brazing, ovens, etc. Supplemental items for cooling such as electronics, computers, and telecommunications, and emergency cooling when the central system fails or is shut down. This is an example of a portable or spot cooling unit. Thermoelectric refrigeration removes heat from one area and places it in another. Electrical energy is used as a carrier rather than a refrigerant. It's used in portable refrigerators, luxury stationary domestic refrigerators, and water coolers, and to cool scientific apparatus. It may also be sometimes used for cooling electronic components in computer systems. Systems have no compressor, no evaporator or condenser or refrigerant. There's no moving parts. The unit is silent and compact, and little service is required. This is an example of a dewiring diagram for thermoelectric refrigeration. We use a hot junction and a cold junction. An input to 120 volts is stepped down in the transformer to 20 volts AC. Current passes through a rectifier and is changed to 20 volt DC. The direct current passes through the thermoelectric module. The junction inside the refrigerator becomes cold, and the junction outside the refrigerator is warmed. The thermoelectric cooling units are used in refrigeration called modules. This is an example of a module. We have a cold plate and a hot plate. We have positive and negative voltages that charge the PNP connectors. A module consists of several cold and hot junctions in series. The letters P and N in the figure refer to the properties of the semiconductor modules. The direction of the current flow into the module determines if the junction is warmed or cooled. A reversing switch is usually included in the electric circuit so the cabinet can either cool or warm food. Thermoelectric refrigerators have low coefficient of performance but are versatile. Many operate on 12 volt DC power or 120 volt AC with a power adapter. They're very popular for camping and picnics. This is an example of a thermoelectric refrigeration.